This one is quite an interesting study. I sort of wanted to take the opportunity also to talk to you a little bit about technique here. So what you're seeing here is basically a grasshopper that's been mounted onto this platform. You can see here that they've used sticky dental wax. I mean, in this day and age, you can probably get away with some blue tack, but the sticky dental wax, if any of you have had, I don't know, braces before, you might be familiar with the way these things work. You apply a little bit of heat and it can be molded, and it sort of forms quite a tough substance, but it's not permanent. In a weird way, it kind of also works like beeswax a little bit. So purely this is just to suspend the animal, in this case the grasshopper, flip it onto its back, you suspend it. It's probably a lot easier to work with a nymph because the wings don't get in the way. And then what you actually do is you actually present the animal with something. It could be a phagostimulant or not, but you present it with something, and then it's hooked up to an electroantennogram. So or basically something that has the ability to measure electrical signals, with the idea that the electrical signals are a proxy for stimulation, right? So here the spikes here refers to more stimulated and less stimulated. The more spikes, the more stimulated, so the more receptive it is to the thing. Now, what you're looking at here, this is where it gets slightly confused. The letters on the top represent the pre-experimental feeding regime. So this is not giving the grasshopper more protein or more sugar, sucrose, carbohydrate, or both, right? This is what they were fed before, and the label up here is what they're being tested against. So let me explain this, right? So what this is showing you here is, say you have some grasshoppers and you satiated them with protein. So you gave them a lot of protein. Then you gave another group a lot of carbohydrates, a lot of sucrose. But then you gave another group a balanced meal, right? Both protein and sucrose. Same with the bottom, except now when you actually run the experiment, now they're completely satiated with either protein or sucrose or both. Then you are testing them against the response to sucrose, meaning to say, now you give them a sucrose substance to check their response. And you'll notice that the protein-satiated grasshoppers basically become particularly sensitive to the carbohydrate because their body requires it, right? So you see a huge spike in the number of peaks that would have been recorded when a protein-satiated grasshopper is now exposed to the carbohydrate food source. So it tells us that in nature, there are these mechanisms in place to help the insect detect what the body requires. And it'll always go for some amount of homeostasis so that they can balance their diet. They become more receptive to the nutrient that they require and that they do not currently have. In the same way, we see that when the reverse happens and you expose the animal to give them some protein source, amino acids, that the animal is more sensitive towards the animal that's been satiated with sucrose becomes more sensitive to it.